Hello everybody and welcome back. Today I thought we'd do something different, and I'm about to finish up building this 3D printer, and I thought I'd take you along for the ride and see if it works or if it burns. I don't know, I haven't turned it on yet. I've just finished putting everything together. I finished the wiring and it's a mess. I set up everything so all the axes are parallel and perpendicular, respective of if they have to be parallel or perpendicular. I prepared the build platform and I'm about to turn it on for the first time. So let's see what it'll do. This printer is a new one. There are a few changed parts on this one. I don't know if this is going to stay. This is just to try it out. It's also slightly bigger than the ones that I usually build because it's 300 millimeters in all directions, and I think that will work out really good because it is still very stiff on the Z-axis. Everything fits together, and also it looks quite good. The green parts are one of my seedling sets. I've started going on shows and showing these things to people, and because I can't afford to just give away sets all the time, I came up with these seed sets. So if I meet somebody and he agrees to make me two more, he gets a green set for a very low price, and way lower than it's even for me to make, but that way I can basically keep on going and giving some of these away. This one here is slightly different because it has a Y switch for two colors or two materials. Let's see how that works out. There's been one change to the original design, and that was that the X-axis home switch is now on the carriage, which doesn't actually change anything, but it improves the wiring because now everything is just tied up in one big chunk of wires, and it's a lot easier to take care of it, and it looks a little bit cleaner, and it works exactly as before. So what else is new? Yeah, I did the setup for the dual extruders. As you can see, these are not TEVO Titans. TEVO Titan extruders have been, they're like impossible to get right now. They're still cheap, and I think I have like 5 or 6 of them on back order, but they just never show up. I reached out to TEVO and asked them if they would just sell some of them to me directly, and yeah, they basically ignored me until I told them what I thought of that, and then they told me, yeah, sure, they'll sell some to me, and I'm supposed to tell them where I'm located, and so I did, and I've never heard back from them again. So these are not the original TEVOs. This is the nice packing that a real TEVO comes in, and it actually says on the box, "Customer satisfaction is our eternal pursuit." Yeah, right. No, not for me. But I've been using these they're really cheap clones of the E3D Titan, but they're also awful. I wouldn't recommend these because the parts just don't fit. If you've got a 3mm filament, fine, use them. for 1.75 millimeters, it doesn't work out. I basically have to put the PTFE tube up to the feeder to make it grab, because they just forgot that they have to change the angle of the feeder tube to the outlet, and if you use them, it's like nothing works. So they're no alternative either. Although they're really cheap. I mean, the set with the extruder and a hot end is just 20 euros. That is really cheap. But it's just a hassle to work with them. Apart from that, yeah, if you don't mind that it just looks bad, and that putting filament in is just a real pain, they'll probably work out fine. Maybe even better than the TEVOs, but I'm not sure. And I have to find something, because I need a lot of them right now, because I'm making a lot of these printers right now. In fact, I've got another one. I've got another one here, ready to go, with no extruder driver, and that just sucks. So yeah, so both of these are connected to this Y switch. The Y switch is just this thing with two PTFE tubes going in, one coming out, and on the inside it looks something like this. I don't know if you can see this. It's just one tube cut open and two coming in, so it basically, it's really easy to grab on, and it works quite well. I'm really surprised. It only took me like, I don't know, half a week to make these in the way that they work out for this one, and no problem so far. So, let's see that. Just checking that I didn't rip out any wires, and let's put the display where you can see it, and let's see what happens. No smoke. The fan is revving up. That's working. I don't know if you can see this here. We're getting the standard screen. It's showing the temperature sensor. It's showing, yeah, nothing except that. Let's just check if the Z end level switch is working. Yep, that's doing something. Right. Let's see if we can move something. Moving the x-axis. What is it doing? Okay, that worked. I didn't want to home it, but it did it all by itself. Well, let's try it with the y-axis. Yeah, that's working nicely. We can't home the z-axis because it doesn't have anything to find, but we can fix that in a minute. Let's try and turn on the heater. Let's turn on the heater, turn extruder 1. So this is set up to be a single heater setup. Both extruders are sharing the same heater, and they're sharing the same information for the temperature probe. So if you change the extruder, heater 1 will still be the main heater. And it's heating up. Let's see if I can hold this so you can see it. So we're seeing the heaters come up. kind of cool. Once it gets above 150 degrees, we can try to move the extruders. Let's move extruder 1. And yeah, that one is moving. Let's select extruder 2. Let's move it. Let's see if it's moving. Yeah, it's moving. Let's turn the heaters off. Yeah, that's working too. I wonder what happens if I turn up the heat on the... Oh, if I turn up the heat on the second extruder, it will register as the heat for the first extruder, which is correct. So, wow, it's working. It's cool. So we'll just let that cool down a bit. Sweet. Steppers are on. All the steppers are on. That's nice. So I'll reset this and get the build platform. This here's the new build platform. This is just a piece of aluminium sheet, 4mm if I remember correctly. I've never used this material before. I've used aluminium, but it was always machined, and this is just flat aluminium sheet, and it's being scissor cut. I don't know how flat this is, but just for this simple tryout, I think it'll do. So we're getting to 100 degrees, and I'll just turn everything off. So let's add the table. So when I built the Y switch on for the extruders, for the materials, I designed it so I would have about 65mm to retract on each material change. I wasn't able to come up with one that required less. If it required less, it got kind of flimsy, and I wasn't really happy with that. So, am I going to take the foil off? Well, why not? It's going to have my fingerprints on it anyway. Wow, sweet. This really looks good. I didn't go with too many design revisions, so I'm still using the screws on the table that are far too long, so I can use the screws to press the switches. You can do it cleaner, but I mean, it works perfectly, so why make something extremely complicated if it just works? Right. Here's the number 2. Well, it's got a lot of tension on it. So that's it for the table part. Right. So let's move the sensor very much down. Yeah, I don't know if I like that. Let's get the power back. Alright, power is back. Let's home the y-axis. Alright, let's home the z-axis. I put the sensor all the way down so it will register a lot way before anything is close to the table, just to make sure that we don't break anything. Wow. That was cool. That was nice. Let's see if we can get a bit closer. Still about 2 millimeters. About 0.5 millimeter. Let's start tightening this down. Hey. And I think we're pretty close. I'm not going to go closer than I am right now. So also home the x-axis, and the printer is set up. That worked better than expected. So now I've got the build platform, which is pretty much where I want it to be. I've got X and Y and Z axis working in the right directions. I know that I can turn the extruders. Yeah, let's try to push something out the extruder. So let's move the x-axis up, and then let's turn on the extruder. Let's go for 205 degrees. That should be enough. And we'll start with extruder 1, which should be the white one. I always start out with very small amounts of filament because it just makes sense. And let's see if the switch will work. Let's get a piece of paper so we can make a mess. Not that one. Not that one either. It's this. Love key mount. Free 6 months extended warranty. Wow, I don't need that. So I'm extruding white right now, and it's not even past the... It's not even past the Y switch. Oh yeah, there it goes. So it's now past the switch. Oh, this is going really slow. So it's now entering the extruder right now. And it should be starting to extrude any second now. I'm not sure that I have these steps per millimeter set correctly for this extruder because there's no manual coming with this, and I'm gonna have to research this a bit. I'm pretty close, but I could be off by a few percent. And we're extruding. Well, let's make a mess. That's kind of nice. So we're getting this to work. And for the next test, I'm going to switch to the computer. Where's my USB? And I'm going to put this into the rant board. Because it's just easier to put all of this in with a keyboard and mouse. And I'm going to see how far I have to retract the filament so it goes back into the switch. So connecting to the printer. The heaters are still turned on. So it's now resetting. Now the heater is still set to 200 degrees, and I'm going to try to retract 50 millimeters and then 10 millimeters. Here go 50, 10. It's stuck. No. Yeah, that wasn't what I wanted. Right, so it could be that either the filament is already too cold. See if we can push it back down. So 70 millimeters is not enough to retract this out of there. is like 110. So let's try again. So the problem with these is that every time you change the filament, you have to pull it all the way back past the bend so the other one can pass down. And you have to figure out exactly how far you're pushing and how much extra you have to give, because some is going to remain. That is the reason why you have to also build a wipe tower. I think I must set up a test for that. Still not extruding. So I'm at 140 millimeters right now. This doesn't really make sense. Because, well, maybe it does make sense. Maybe it makes perfect sense. 140 millimeters. So next thing that I would like to do is try and set up something that prints something really easy with extruder switching, but I don't have any really easy to color prints, so I'm gonna have to get some, and I will have to set up 2 materials. That is, yeah, that's the next thing. If all of this works out, I want to try a mixing extruder, an extruder where you can actually push 2 filaments in at the same time and they will be mixed inside. Although these extruders are very prone to oozing and they don't have a really good print quality, and I've tried another one of these and it was just a total mess because filament kept coming out everywhere, and not only on the print bed. So this is pretty cool. So let's try and get something simple set up. So I don't know if the center of this printer is already correct for everything, but let's try to print something very simple. And for that we need blue tape. Just a bit. Yeah, that didn't work. I really have to buy some new knives. I'm making a complete mess out of this. Okay. First, this knife is no good at all. Since I don't know if the centers are set up correctly, I'm going to put this on a little bit off center. Now let's just try something that worked on the other printers. Oh, let's just try something and then stop it. So one of the big issues that I've been having with these level sensors is that they are very sensitive to temperature. My work area is about 14 to, well, something about 14 degrees in the winter, and that's a real problem for these sensors because when I set them, they were made for, I don't know, 20 degrees, and now in the winter it's just not really working at all. So apparently it's working, but the height is not correct. And also the table appears to be very much crooked, because you can see the z-axis is correcting quite a lot. And I really have to fix that. But for a start it's okay. Extruder number 1 seems to be working. Neat. So, yeah, that was quite nice. I think we got something to work, and I can start working on this from there on. So, that's it for today. Shh. Well, it's been 2 days since I recorded that previous part, and I can safely say that all of the testing that I did on the new extruder and the Y switcher were a complete disaster. In fact, I couldn't get this to print anything. Single color would work, but nothing else. And, well, I did what any other normal German would do. I, well, retired to some thinking and some chocolate and a little bit of beer. And once the hangover had passed, I was actually able to think about this in better detail, and I talked to a few people about this, a few of the kids who visit my classes at school. And it turned out that the main issue was not the splitter, it was the way that filament retracts. And I don't know if you can see this, but there's a very fine hair of filament that just keeps on pulling itself, and this is like almost 10 centimeters. And that was a real issue, because I would retract and that little strand would still be sticking in there, and it would actually be sort of a blocker at times, because this wouldn't come off easy. There could be a large blob at the end of this, and that was one of the things. But the second thing that was a lot worse than that was these throat pieces that are screwed into the coolers and that are attached to the heated blocks. They've got a very peculiar profile inside of them, and I think I'll just draw this. Let's see, got some pen and paper. So if this is the the throat. Then the throat is 7 millimeters at the top, and it gets smaller. Then there's the throat part, which is like 4 millimeters, and then it extends back out until it is about 5 millimeters. And inside there is 4 millimeters for the PTFE. Then it gets down to about 1 millimeter, and then there's a 3 millimeter shaft or bore right through till the end. And this bore here, this part right here at the edges, that was the problem, because the PTFE tube actually goes in here, and it has the 2 millimeter inside, and if the filament is not really clean, then it will actually get wedged right on these edges here, and it can't go past that. And that is the only reason that I could find that my filament would get stuck in here, because this is just like 1.8 millimeters and the filament is 1.75, and I couldn't get past that. So I started looking out for other extruders, and the only one that I could find that has a slightly different design is the original E3D V6 Lite. The original, which has a larger throat, but I couldn't get that quickly enough, and they're getting hard to source. So I examined this one here, and I found out that there's another piece of PTFE tube in here which has 3 millimeters diameter, and I didn't know what to do. So I took one of these and I took a drill and I just drilled through here, right through the center, right through it. That actually meant that if I was able to make a PTFE tube that was 4 millimeters up till here, and then 3 millimeters through here, that would be a winner. And I don't know, it took me quite a while to figure this out. In the end, I took a piece of PTFE tube and I stuck a drill in there, a 2 millimeter drill, and I took this to my lathe, and with the lathe I tried to remove the outer PTFE until I had 3 millimeters, and amazingly this worked. In fact, it worked good enough to actually put this in one of the throats that I drilled, but it wasn't centered. So I took even more time and I made this. This small little piece here is steel. The inner diameter is 2 millimeters, and there's another step on here, I don't know if you can see this, which has 3 millimeters. So if I put any piece of PTFE onto this, and this fits really snug, and if I put this into my lathe, and if I set the cutting tool to exactly this ridge and I cut back, I get a wonderfully centered piece of PTFE that has a leading edge with 3 millimeters and then goes up to 4 millimeters. So now I was able to make some of these here, and they are indeed 4 millimeters, and if you pull them out, you have the inside that is 3 millimeters. And they look very good, and these are the ones that I'm going to try to use now. And the fun thing is, these sets of V6 clones that I usually buy actually come with 5 throats. 4 of these 5 throats are PTFE lined and 1 is solid center. It's all metal. And I'm going to try these out. So I have enough to train on, and I'll try to figure out if this works out well, and I really hope so. So this is where I'm trying to go with this printer right now. I still have other things to fix, like the build platform that doesn't seem to be seated correctly. I'll figure that out, and I hope I can figure out the color mixing. And if nothing else works, I will go to a full mixing extruder and just forgo the Y switcher. But for a start, I want to use this, and I will be using this, and I won't, or I hope that I won't have sticking filament in this in the throat. So yeah, that's the good end to a really unnerving testing session. It took some time to figure this out, but I thought I'd put this at the end of this video. And I really like the idea of having a single piece of PTFE going all through, although this this connector has a throat, and if it works out, it's great. If it doesn't, I'll report back. So another end to this video. Thank you for watching, and bye.